Welcome back to part two of your examples. So now we're going to focus more so on using a graph. So previously we used a table and your calculator. Now we're going to look at a graph. So how do we evaluate using a graph? Look at the x value for that value, move up or down to find the point on the graph with that x value, and then look across, either left or right, to see what the y value is for that point. I know that was pretty stinking confusing, so let's look at example 4. Use the graph to the right to find f of 1. Okay, so f of 1. So notice that the 1 is inside the parentheses, so 1 is the input or x value, so x equals 1. So x equals 1. Boom. Notice that the graph is on the top. Let me grab a ruler because Lord knows I can't draw a line. Then we go, boom. Okay, so it crosses the graph here. If I draw a line over to see where exactly it is on that graph, I see that it's y equals 4. So f of 1 equals 4. Okay, so then for number 5, we're going to work backwards. Use the graph to the right to find x. Oh, that's too light. You guys can't see that one. To find x when f of x equals -2. So it's on the outside of the equation, which means it's the output. So I'm telling you that y equals -2. So notice, also remember that f of x equals -2 is the same as y is -2. So now we're going to work backwards. I'm going to look up to -2, and I'm going to draw a line over to see where my graph crosses. So x equals -1. So f of -1 is equal to -2. Okay? So let's go ahead and look here. So given that f of x equals x squared minus x plus 3 and g of x equals 1/2 x plus 11, find these two different things. Last year, this problem, or a problem very similar to it, confused people like you wouldn't believe. And the reason why it confused people is kind of funny, but it's also kind of concerning. And the reason I say that is because we have one equation that's f of x and one equation that's g of x. And in these two examples, I tell you explicitly which equation to use. Okay, last year a lot of kids were just plugging things in wherever they wanted to. You cannot do that on your tests. You cannot do that on the EOC. You need to be very specific and conscious about which equations you're plugging into. Okay, so notice part A says F and part B says G. Okay, so let's go ahead and do this. Okay, and I will be using the calculator to help you out a little bit to show you how I personally would solve these. Okay, so for part A, we have f of -1/2. So I know I'm going to plug into the f equation. Everywhere there's an x, I'm going to plug in -1/2. So we have f -1/2 equals, and we always use parentheses when we plug into equations, -1/2 plus 3. So we could do this. We could turn our calculator on. -1/2 squared minus -1/2 plus 3. Hit enter. I got 15/4. If I hit math decimal, it'll turn it to a decimal for me. So f of -1/2 is equal to 15/4, or 3.75. And one of the things that I could do to check my answer is go to go to y equals and type in my actual given equation, x squared minus x plus 3, and look at the table. So I want negative 1/2. Notice it's not on here, but it's between 3 and 5. So I'm going to go to table set. Right here, I'm going to do 0.5 instead of 1. So that way when I go back to my table, it changes it by 0.5s. So if I do negative 1/2, I get 3.75, 3.75. This is my answer. Okay. So now I'm going to go back to, I'm going to hit the window or second window. And for table start, I'm going to clear it. I'm going to put 1 again because I want to make sure that my calculator is good just in case. So looking at B, find G of 5. So everywhere there is an X in this second equation, I'm going to plug in 5. So we're going to take G of 5 equals negative 1/2 5 plus 11. Okay, so PEMDAS tells me parentheses first. So I have, what is that, 16? G of 5. 16 times negative 1/2 is negative 8. Well, let's just double check and see. So if I do alpha y equals enter negative 1/2. Now, if you want to use negative 0.5, you can do that too. Parentheses 5 plus 11, negative 8. And just to double check again, so negative 0.5 times x plus 11. Graph, we want to go to positive 5, negative 8. So there is there's my answer. Okay. Ooh, okay. So now we get to play around with number 2, a graph. Yay. Okay, use the graph of the function f to answer the questions below. F of negative 1. Okay, so if f is negative 1, or I'm sorry, f of negative 1 means that x equals negative 1. So when x equals negative 1, if I draw a line, boom, that's where it crosses my graph. That means it equals negative 1, negative 2. So f of negative 1 equals negative 2. Okay. F of x when x equals 3. So what I want you to do is substitute 3 in for x. So we're going to have f of 3. So now we're going to count over 1, 2, 3. See that it crosses my line here. If I draw that horizontal line over, it crosses at y equals 2. Equals 2. That's a 2. Okay. So then this last one, find x when f of x equals negative 3. This is the same thing as y equals negative 3. Okay? So when y equals negative 3, we're going to start at our origin, count down 3, 1, 2, 3. And if I draw a horizontal line, I see that it crosses my graph here. And if I count up to x, that's negative 2. So f of negative 2 is negative 3. Okay. So this last one, given that f of x equals 3 minus 2x has a domain of negative 5, 0, and 7, find the range. So we know our x values. We know what the domain is. X values. So we want to evaluate with those x values. So we're going to take f of negative 5, f of 0, and f of 7. And we can plug them all in, or we can use our calculator. So for this one, I'm going to use the calculator, and I'm going to plug in this equation right here, exactly the way it's written. So remember, we know f of x is the same thing as y, so I'm going to plug in 3 minus 2x. And I'm going to go ahead and look at the table. So the first one I need to look at is negative 5. Gives me a positive 13. Okay. 0, when x is 0, y is 3. And 7, negative 11. So find the range. And we always list from smallest to largest. Negative 11, 3, 13. Okay, there's our range. Okay. So example, number 4. All right, you are planning a trip to a Rangers game. Parking costs $15 and each ticket costs $35 or $34 each. Write a function to express the cost of attending the game based on the number of tickets purchased. Okay, so parking costs $15. That is a flat cost. That means we are only going to pay it one time. Tickets cost $34 each. That means 34 times something is going to be the total number of tickets. Okay, so all of our functions are always going to be in the form f of x equals mx plus b. You should be familiar with that. That's the equation of a line. If you're not familiar, it's fine. We're going to talk about it next week or something. I don't know. So b is our one-time fee. So we know parking is a one-time fee plus 15. X stays the same. Tickets are $34 each. So here's our equation. Okay, 34x plus 15. Okay, so over here I have a couple of questions to ask you. Looking at the table, okay, then pick the correct table. So this is what I would do, honestly. I'm going to go to, here, 34x plus 15. And I'm going to look at the table, okay? See which one matches up. 149, 2 should be 83, so it's automatically C. Okay, so the number of tickets is our X value. The total of cost is our Y value. So over here, it asks, what does the domain represent? Domain is the number of tickets. And the range represents the total cost. Okay, how many tickets were purchased if the total cost was $151? So what exactly does that look like? So for that one, I'm asking you f of what equals 151? Okay, because I want to know what x value, how many tickets, give me a total cost of 151. That's the best part about your calculator, because if you scroll, you find 151, your x value has to be 4. If at least 2, but not more than 4 people attended the game, what are the domain and range? Okay, so if at least 2, but not more than 4, so 2, 3, 4. So number of people So these are our x values, which means cost. These are our y values. So 2 is 83, 3, 117, 4, 151. So domain 2, 3, 4. Range, excuse me, 83, 117, 151. That's a squiggle. Okay?